Hello, my name is Zhao Wang. Today I'll be presenting our startup concept, AstraLux, an innovative adaptive lighting solution. 40 million Americans suffer from insomnia every year. Insomnia is a sleep disorder that prevents individuals from achieving sufficient sleep. It is also the leading cause for depression. To address this problem, we'll need to understand the circadian rhythm and its implications on our sleep patterns and overall health. The circadian rhythm regulates the sleep-wake cycle, which controls when we are tired and when we are awake. Environmental factors, mainly light exposure, has the most significant impact on regulating it. Harnessing the power of blue light is crucial for controlling our circadian rhythm because of its ability to completely rewire our sleep schedules. Despite the stigma around blue light's effects on the human body, it is able to energize and revitalize with minimal side effects if deployed correctly. Enter AstraLux, an modular adaptive lighting solution centered around users and driven by AI, aimed at alleviating insomnia through regulation of the circadian rhythm. AstraLux puts the user at the center of our system. That is why the hardware ranges start with a biometric tracking bracelet that tracks vital information necessary for our algorithm and AI to make adaptive decisions. The Smart Bridge Hub enables all of the bulbs and sensors to communicate. It connects with the cloud via Wi-Fi and communicates to the bulbs via Zigbee. Our AstraLux ultra bright light bulbs are completely color and intensity adjustable. The light intensity ranges from 200 to 3200 lumens. Each bulb consists of 30 RGB LEDs placed in a circular pattern, which allows the light bulbs to be directionally adjustable. These smart bulbs are compatible with most home light sockets, making them easily expandable. So, how does it all work? This is Alice. She suffers from insomnia. We're going to explore how AstraLux can help. Alice begins her journey with AstraLux by filling out a brief survey on the mobile app. This information, combined with input from her biometric tracker, will be integral for AstraLux to determine initial cycle of therapy, which is the balance between light intensity, color, direction emitted at different times to optimize circadian rhythm regulation. As the treatment progresses, AstraLux will incorporate more and more of the biometric data sets collected from the user to make decisions and adjustments to the pattern. Here, Alice is doing some work on her computer. And here is the floor lamp set she's installed her AstraLux bulbs in. Soon she begins to feel sleepy and tired, but it's only 4 p.m. That's no time to be taking a nap. The AstraLux digital tracker one on her wrist senses that she is getting sleepy, but AstraLux knows that it is far too early for Alice to be sleeping, and that sleeping now will only cause her to be unable to sleep later at a healthy bedtime that night. AstraLux increases the light intensity and the blue light emission in Alice's office incrementally to give her a boost of energy, so that she can carry on with her work and maintain a healthy bedtime. When Alice is no longer exhibiting signs of sleepiness, AstraLux slowly and intelligently dims surrounding lights and reduces blue light output, easing Alice back into her previous working state. We understand that regulating one's sleep through an artificial means can be scary. It sounds as if it's coming straight out of a sci-fi horror movie, right? But it doesn't have to be that way. AstraLux provides a maximal control and transparency to the user. Everything AstraLux does and why will be clearly relayed to the user via the app. Users can stop or pause the AstraLux system anytime from anywhere using the app. The data we collect through biometric and environmental sensors will be encrypted and protected in the highest standard to ensure user privacy. Users will be able to access their data and digital insights about their sleep cycle and overall well-being in the app. Taking input from biometric and environmental factors, AstraLux's cloud-based computing platform uses advanced algorithms to produce optimal lighting patterns for any situation. AstraLux is initially using previously trained algorithms to estimate light output changes, but as time progresses, AstraLux will monitor the success rates of treatment cycles on the user and relay data to the AI-driven feedback platform, which makes incremental adjustments. Based upon our previous example, if AstraLux is unsuccessful or less than successful in keeping Alice awake in our working scenario, the AI will analyze what happened and make recommendations for the system to try different approaches such as more intense light or quicker illumination time. We provide a highly adaptive content-based recommendation system of artificial neural networks with an assortment of pre-trained algorithms designed to accurately predict how the probe units should be adjusted to maximize sleep quality. The raw data from the user response collected by the biometric bracelet will be narrowed through each weighted layer of perceptrons from the binary outputs to eventually leading to the desired result. Here are some of the applications AstraLux can be deployed in. AstraLux can be deployed in home, office, and even hotel applications. Our total addressable market comes in at 22 billion, our SAM comes in at 2.3 billion, and our share of market by 2026 comes in at 9.7 million. We operate off a transactional model. Our two main streams of income are retail sales to consumers and commercial sales to commercial businesses. Here's our competitive landscape, here's our timeline to roll out, and here's our team.